All right, so here we're going to show you how you exploit uh, a Windows software through the libraries by making fake libraries. So we're using the Windows 11 machine with tools that's set, and there's some commands to execute. And as usual, I'm going to open them on my other screen so I can follow. I can do this without flipping back and forth so much. So here I have to make a working directory. So let me go in here and get, I do need an administrator prompt. Okay. So I'll make an administrator terminal. All right. And then I see my name is student. So I'm going to have to make a directory desktop dill proxy. Okay. Make directory desktop dill proxy. Okay. All right. And then I want to go in there. Okay. And now I want to copy C tools. The program I'm going to exploit is a sysinternal tool called bginfo that just prints some information on the desktop. But it turns out this program has a security flaw, which I'm going to exploit. So now I've got that executable here. All right. So the first thing we want to do is find the security flaw. And I've already excluded this, so we're fine. Okay, we're going to view the dills in Process Monitor. So let's get Process Monitor going. And I have to use the A version on this ARM-based Windows. All right. And it runs as administrator. And here it is. Okay, and now I want to have a path ends with version.dil and process name contains bginfo, which I've already got set here. Those are the two filters. And so now it's sniffing and everything is being left out. So now I want to run that program. So bginfo64. I run it and then I click OK. And as you see, I captured some events here. So I'm going to stop it from sniffing and look at the existing events. And now look at what happened with version.dil. What it did was it tried to load this library first from this desktop dill proxy folder. It first looks for that library in the current working folder, and only when it doesn't find it does it go to see Windows System 32 where the real one lives. This is a vulnerability that's applied to Windows programs all the way back to the original Windows NT server. And it makes it possible to attack it with what's called companion Trojans. I can make a dill file in this folder and it will load it instead of the real official dill. So that's pretty good. So the first thing to try is just using a straight up malicious dill. And you can make a malicious dill with Metasploit. And Metasploit's already installed on this machine. Here's the program that will create that file. Let me copy the code here. All right. So I paste it in there. You run your Metasploit, which is already installed. I can make a Windows 64-bit shell bind, which will start a listening shell on port 4445. And it's going to make a dill, format dill. This will create a program called version.dil. And all it does is when a dill is connected, when you load a library into an executable, the first thing it runs is the function dill main. Dill main prepares the library for use. And this Metasploit tool puts the malware in dill main. So as soon as the library is loaded, the malicious activity takes place. And we'll see what this does. There we go. It runs a little slow. So does Ollie, because they're clearly running through some kind of interpreter to run Intel code on this ARM processor, but it seems to work. So here it is running. Okay, it's done. It ran, and it created a library called version.dil that's very small because all it has is the dill main method, which is malicious. All right, so now if I run process monitor again, and the same filters are fine, and it is running. You see the events go by. So now I run bginfo again, this one. All right, and there's my events. And now I'm going to go here and stop sniffing. All right, and here it loaded it. File locked, invalid device request, getting upset, file locked. And the bginfo program never actually ran. Um, it looked for it, but the application was unable to start correctly. And when I did it before, I actually got an error message showing me that. But here I could see the window never popped up. It never actually ran. So I don't think it started the listening shell. If it worked, I'd be able to do netstat minus an pipe more, and I see a process listening on 4445, and I don't see one. So it didn't work. It didn't start the listening shell. Instead, it crashed. And the reason is because this actually uses that program, that library called version.dil. Now, there's another project that you really need an Intel machine for, which I'm not going to bother because it's not that different. But this earlier project here, 125 or 124, is where you actually do it this way. If you have a library that is loaded but never used, which is a fairly common mistake developers can make, then you can actually use this kind of malicious DIL to exploit it because it never actually tries to use any of the functions, so it doesn't crash. It just loads the library and runs the malicious part that Metasploit puts there. But this program does have a vulnerability, but it's not that vulnerable. It needs to actually use the functions in the library. So what you have to do is you have to make a DIL proxy. You have to make a program that will have all the functions of the real version library. And you can do that with DIL Export Viewer, which should be already installed on here. DIL Export Viewer, there it is. All right. All right, and so in here, I'm going to load functions from the following DIL. I can specify the program, and that's going to be C Windows System 32, and I don't want kernel32.dil, I want version.dil. All right. And then I just say OK. And it's going to show me the functions, presumably. Wonder if I need to run it as administrator. No, load functions from the following file. C Windows System 32. See if I can figure out load functions list. Load functions from the DIL file. C Windows System 32 version.dil. All right. Well, maybe I'm not going to be able to do it on this machine. More likely, I'm making some kind of mistake. Let's try browse. Is there version.dil in here? There should be. There it is, version.dil. Open. Okay. I'm afraid it's not doing anything. Let's try Task Manager. 0%. Well, that's annoying. It's so close to not working. However, I think I can just go ahead anyway. No, I can't. I don't have stuff I can copy and paste from there. Well, how annoying. Well, all right, I guess I'll mark this project, say it doesn't work yet on ARM. I thought it would. All the other pieces worked. I didn't know this particular program would fail to work. Let's just try running it as administrator and see if that makes it any better. But I'm afraid uh, something about this program is not correctly going through the oh, it probably can't read that ARM DIL file. That's probably, this program probably assumes that the file is a Intel-based DIL to read, and it can't understand the ARM-based DIL. That is probably the problem. Okay, so anyway, let me just talk about this one then. The point is, I thought I checked every bit of it and it was going to work, but that one feature is not going to work. Anyway, if you run it on an Intel-based machine, it'll find this. It'll find all the API calls in that library. And once you have them, you can then create a program. And you make a program called DIL proxy. You have a script here to parse that and make the right layout. And you end up with these pragma commands, which will connect to the real version in something called version_orig. These are C++ commands that tell it where to go when those functions are called. And now you can create a C++ file including all that information. And then you can make an exploit which will run when that library loads, and that will call a function called exploit. And in this case, I made it so it's just going to run a batch file in the default directory. I think perhaps in the root of C, I forget. Just going to find payload.bat and run it. And I made a payload.bat file that just marks the desktop with a file named pwn just to show I have control. And you can build it in Visual Studio. You just have to build this DIL in Visual Studio. Building this kind of thing in Visual Studio is kind of tricky, though, because Visual Studio has a lot of properties to adjust and a lot of fiddly little bits you have to get right. So you have to be careful. Set the right release here and turn off, make multi-threaded code and don't use pre-compiled headers, whatever those are. You have to turn them off. Then you can build a DIL, put the DIL in the working folder, and what you do is you copy the original DIL from System32 into your folder with a different name, version orig. You put in the one you created with Visual Studio, which is a proxy, which would every time the bginfo tries to call a function in version.dil, it will just forward that to the real original DIL and run the correct function. But when it loads, it will also run malware and do a malicious activity. And so now when you run that program, it will create this file on the desktop showing that it ran the payload.bat. So it's pretty cute and a pretty sophisticated technique. And I'll put a mark here saying this one is not yet ready for ARM, but it's a good project to do to understand how libraries are used in Windows.